Advanced Algebra, Chapter 7, Lesson 2, and we're going to do a few examples of dividing radicals and then rationalizing denominators. And I really want you to watch these examples because I'm going to do a couple things that we haven't talked about in the lesson, which are kind of mathematical tips that you can do that will help make the rationalization of these larger indexed radicals a little bit easier. So even though you may know how to do these, maybe you'll learn a couple of kind of tips or tricks of the trade, so to speak, that might make your life a little bit easier in the long run. And again, especially with these higher indexed radicals that we'll be dealing with. So let's take a look at number 2 here, and I have 3 fourth root of 4 divided by fourth root of 1024. The 4 does go into 1024, so I can reduce that. That's going to go 256 times, so that's going to leave me 3, and then the fourth root of 1 would just be 1, so I don't do anything else with that, over then the fourth root of 256. Now, if you jump right into rationalization here, you'll notice that we have one 256 number, and to rationalize it, I would need 3 more. So if I was going to just jump into rationalization, I would have to do the fourth root of 256 cubed. Now, that's okay in the denominator. That's going to end up with just 256, but then you're going to have this cube root of this very large number. Imagine 256 times 256 times 256, which you would then have to do some prime factoring with in order to reduce. And so before we do that, again, if we simplify before we rationalize, that was going to eliminate some of the complicatedness that we might bring otherwise. So before I rationalize, I want to simplify this radical. So I'm going to do 256, and I'm going to do my prime factorization with this value here. So this is going to be 64. 32, 16, 2, 8, 2, 4, 2, 2, 2, 1. So because it's a fourth root, 4 of these, 1, 2, 3, 4, become a single 2, and 4 of these become a single 2. So I end up with 2 times 2, which is 4. So the fourth root of 256 simplifies to 4. So by simplifying, I take away the need to even rationalize. So you can see if I simplify before I jump right into rationalizing, the denominator can sometimes be a perfect root, therefore eliminating the need to rationalize first. So simplify before you rationalize is really something that will be very helpful to you and something that you want to do before you just, again, simply jump into rationalizing. I want to look at number 8 here, and I'm going to do number 8 a couple of different ways so you can see how, again, if you kind of understand what's going on a little bit deeper, you can save yourself a little bit of trouble. If you want to do it the other way, it'd take a little bit longer and maybe have to deal with some larger numbers. It's still doable, but hopefully you can see the difference between some simplification tips that you can use that should help shorten things up a bit. So first I notice that I have some non-radicands that I can reduce, so I'll reduce those to 1. And then I notice that the fourth root of 5, the numerical radicand, I'm not going to be able to reduce anymore with the 1 in the denominator, so that I'm going to have to leave and deal with. X squared, I have 2 x's down here, reduces with 2 of these, so I end up with x squared in my numerator. So I'm going to split this up again so you show you 2 different ways. So the first step, I end up with the same radicand or expression, so there's nothing I can do here. Now, if I notice and that 4, there is no fourth root of 4, so that means if I want to rationalize this denominator, I need 4 of them because my index is a 4. So I need 3 more 4s in my denominator in order to make this a fourth root possible. And I'm going to have to then do the same thing in my numerator. So my numerator then is going to end up being, I multiply the 5 times the 4 cubed. So that's going to be 5 times 4 cubed, which is 64. All right, and then I'm going to have the x squared over, and then I have 4 4s in my denominator, so that's going to come out as a single 4. Now, here's where I have to do more simplifications. Now I could multiply the 5 times the 64 and get 320 and do my prime factorization. But I don't want to do that because if I multiply and get 302 and then I just divide it out, I'm going to end up back here where I started. So I'm going to simply prime factor each one of these. So 5 is already prime factored. So the 64, if I was to redo 64 to prime factor 64, I have 32, I have 16, and then I have 8, and then I have 4, 2, 2, 2, 1. Now again, I'm looking for groups of 4. So I have 1, 2, 3, 4 2's here that I can take out in the numerator as a 2. And then I have 2 left over which I can't do anything with, so I'll have to multiply those back together on the inside. So this is going to be then the 4th root of 5 times these two 2's, which is 4, x squared over 4. I now have a number out here that's a non-radicand, which I can reduce with this non-radicand, which reduces to 2. So simplifying all that then gives me the 4th root of 20x squared over 2, and you can see that that is the answer that I got. Now this extra step of multiplying and simplifying the numerator, I can kind of get away from that if I do a couple of things here. And that is to do this. Instead of, let's say, multiplying or rationalizing by multiplying by 3 more 4's, let's break this into its prime factors. In other words, 4 is really the same as 2 times 2, is it not? 2 times 2. Those are the prime factors if I did my upside down tree. Now as I see this, I need the 4th root of 2. What do I need? I need 4 2's. Okay? I don't need 3 4 or 4 4's. I just need 4 2's, the same thing. And so really I only need to multiply this by 2 more 2's in order to have 4. So then I just multiply my numerator by 2 more 2's, and you'll notice then that nothing up here reduces, so I have the 5 times the 2 times the 2, which is 20, and then the x squared, and then I have 4 2's down here, which the 4th root of 2 to the 4th power is a 2. So you'll notice I have the answer here in one step, rather than having to do this extra step in my numerator. If I have to rationalize, let's list the prime factors, because then all I have to do is multiply by the number of prime factors that I need in order to give me the 4th root. So you can see this way I think is a little bit easier if you recognize what you want to do. Again, you can do it this way. Just remember that you have to continue to simplify and simplify and simplify until you can't simplify any further. Okay, so let me do a couple more examples and hopefully that will help clear up, or at least give you another type of problem that you can look at and see that might be helpful for you. So let's do number 14 here. I have 2 non-radicals that I cannot do anything with, so I'm going to have to leave those. I cannot reduce the numerical radicands at all, so I'm going to have to keep those. I do have the x squared and x squared, that's going to reduce to 1, so I don't have to do anything else with those. And then I have 1y up here that I can reduce with 1y here, leaving me 3, so I have 2y cubed. Now again, before I jump into rationalizing, I want to look to see if I can't simplify my numerator or denominator any further. The numerator I cannot simplify any further. However, the denominator, I have 3y's cubed, or I have the square root of y cubed. The 2 and the 3 goes one time, and so then I'm left with just 1y underneath. Now I cannot simplify any further, so I am going to have to rationalize this denominator. So this is a square root, so I need one more 2 and one more y in order to make 2. Alright, which means I must multiply my numerator by the same thing. So I still have the 5 then. The radical 3 and 2 I multiply together to get 6, and then I have the y. And now I already have this 2y on the outside, but now I have another 2 that comes out, and I have another y that comes out because now I have 2 of each. So I'll need to multiply those together to finish this off. So I have this 2 times 2, which is 4, and this y times y, which is y squared. So I have my simplified version. All right, let me look at another one. Now, remember, we want to simplify first, and remember what we said before. When we have an odd power root and we have a negative sign, the negative sign always comes outside. So that simplifies. The 10 and the 32 are both divisible by 2, so I can reduce those. That divided by 2 is going to be a 5, and that divided by 2 is going to be a 16. Okay, and then I have a k squared and a k squared that reduce, so this is what I end up with. Now again, before I jump into multiplying this by 2 more 16s in order to make 3, why don't we prime factor 16 and see if we can't reduce that any further. So that's 2 times 8. Now I'm going to stop right here because I know that the cube root of 8 is 2, so I know that I'm going to have a 2 outside with a 2 left. So that's going to be negative then the cube root of 5 over, and then I have 2 cube root of 2. That's 16. Now I do have to rationalize my denominator. Now I have 1, 2 as a radicand, and I need 3. So that means I'm going to have to multiply by 2 more to give me a total of 3. That means I have to multiply by 2 more in my numerator. So now we have the cube root 5 times 2 times 2, which is 20. Now I already have this 2 outside, and now I have 3 tubes under my radical, so those are going to come out as 1 because I have 3 of them. So then I'm going to have negative cube root of 20 over 2 times 2, which is 4. So this would be the rationalized version and divided. So if we take a look at number 11, I have a non-radical 2 that I can't reduce with anything else, so I'm going to leave it. The 3 and the 15 reduce, and then I have 1m up here that can reduce with one of these. So this numerator simplifies really to just the number 2, and then the square root of 1, which is 1, over, and then I have the square root, I think I said cube root, square root 5n cubed. Now, before I go ahead and rationalize, I want to continue to simplify. So I can't do anything more with the square root of 5, but I can do something with the square root of n cubed because the 2 goes into the 3 one time with 1 left over. Now, in order to rationalize this, it's a square root, so I need 2 5s, so I need 1 more. And I need 2 m's, so I need 1 more. So again, because it's a fraction, numerator times the same thing. So that's going to leave me 2 square root of 5m, and then I already have an m outside, and then these 2 5s are going to come out as a 5, and then these 2 m's are going to come out as another m. So simplified then, that's going to be 2, 5 square root of m, 5, and then m times m is m squared. So I have my divided radical and then my rationalized denominator. All right, so I hope those are helpful. Hopefully you picked up on a couple of ideas there that will help you simplify these before you rationalize. Just make sure that your final answer does not have a radical in the denominator and that there's nothing else that can be simplified or reduced.